Earth. The third planet from the Sun. With an equatorial diameter of 12,756 kilometers, it's the fifth largest planet in the solar system. But still, it's a speck compared to the Sun. It makes up as much as 99.8% of the total mass of the solar system, and it is so large that almost 1.3 million planet Earths can fit inside of it. Yet, our star is tiny compared to the really big stars out there. Pistol Star. This blue giant radiates as much energy in 20 seconds as the Sun does in a year, and its stellar winds is more than 10 billion times stronger than the Sun's. But why stop there? Meet VY Canis Minoris. It is so big that it would take an airplane 1,100 years just to circle it once. And if placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter. And then there is this monster, GY Scuti, the largest star ever discovered. With an average median radius of 1,708 solar radii and a diameter of 2.4 billion kilometers, it is estimated to have a volume staggering 5 billion times that of the Sun. That's equal to more than 8 times the distance between the Earth and the Sun. So when you look up into the sky and realize that it carries on forever, and the universe is only expanding, it gives you a real sense of perspective. We are insignificant down here on this little rock, but a miracle at the same time.
Sophisticated telescopes have now identified nearly 300 planets that are located well beyond our solar system. They're known as exoplanets. The most peculiar exoplanets are pulsar planets. Unlike most that orbit a star like our Sun, these planets orbit a fast-spinning neutron star called a pulsar, which emits a pulsing radio emission, much like a lighthouse. In the 1990s, scientists actually discovered a trio of pulsar planets about 900 light-years away, located in the constellation Virgo.
If I had my say, they'd probably go down as the weirdest planets in the universe. And these planets are all very close in to the pulsar. Now, that's no place for a planet to exist. Nobody expected to find planets around these things because a pulsar, or a neutron star, is the remnant of a supernova explosion. This star has ripped itself apart in one of the most violent, chaotic explosions known in the universe. So what were planets doing there? This was a real surprise.
There are 3 of these planets, and 2 of them are about 4 times the mass of the Earth, and the third planet is about twice the mass of Earth's moon. So very small planets indeed. In fact, they orbit so close to their neutron star primary that they could actually fit within the orbit of Mercury. So they're very close in.
The enduring question is how these planets survived the supernova event at all. If the same thing happened to our Sun, the planets in the inner solar system would have been vaporized.
If those planets that we see were there at the time of the supernova and they survived it, they certainly would extinguish any life that might have been on those planets. There's no hope for that. Just the power and the energy and the radiation environment of the supernova would make it pretty lethal to anything.
If the 3 planets weren't orbiting the star at the time of the supernova explosion, then how did they get there?
maybe these weird pulsar planets formed from the debris surrounding the supernova, the exploding star. Maybe there was a disk of material that was shot out, but it didn't quite escape, and it left a disk of debris from which planets then formed. We don't really know how these weird pulsar planets form. They challenge all theories so far.
Pulsar planets shed startling new insight into the formation of solar systems throughout the universe.
If the pulsar planets formed after the supernova explosion, then they're important because they indicate that planet formation can happen in rather extreme, unexpected environments. Maybe you don't need something quite as orderly as the gas that formed our own planetary system. So that's really cool. But if the planets were there before the explosion and remained bound to the star, that's an interesting challenge to theory as well, because it shows that somehow planets can remain bound in some cases.
Pulsar planets are oddities, but the neutron or pulsar stars they orbit are also quite bizarre.
Neutron star material is incredibly dense. It has a very high mass per unit volume. In fact, it's as dense as an atomic nucleus. So if I had a shovel full of sand and this were actually neutron star material, it would weigh as much as Mount Whitney in the Sierra Nevada range in California. It would have as much mass as a mountain. And a bucket full of this neutron star material would weigh as much as Mount Everest, the biggest mountain on Earth. Now, I can lift a bucket of sand quite easily, but if this were actually neutron star material, there's no way I could lift Mount Everest. That shows how incredibly dense neutron star material really is.
There are two types of neutron stars. Pulsars that spin rapidly and emit beeping radio pulses, and magnetars that spin slower and emit energy from magnetism. Magnetars, which are much rarer than pulsars, have the strongest magnetic fields known in the universe.
There aren't any places on Earth where you can find magnetic fields as strong as you find them in a magnetar. But there's kind of a parallel with this Tesla coil. The Tesla coil is originally experimented with by Nikola Tesla, who was trying to figure out how to provide electricity without having to wire homes, but actually provide electricity through the air. The Tesla coil has a big voltage difference, about 500,000 volts between the ball in the middle and the cage that surrounds it. And that gap is a release of energy that when the electrons fly through the air, releases a tremendous amount of energy that you see in those sparks. A magnetar is kind of the same thing. It's a release of energy that you see in gamma rays and X-rays.
Magnetars can release gigantic bursts of energy, not in a periodic way like a pulsar, but rather sort of at random. Something happens to the crust, like a starquake, and a bunch of magnetic fields come together and release a tremendous amount of energy, which gets turned into X-rays and gamma rays.
Magnetars and pulsars are both strange stars, but scientists have discovered something even more bizarre. A star that acts like a pulsar and a magnetar. NASA's Rossi X-ray Timing Explorer has observed this unusual star ejecting 5 colossal outbursts of energy in the form of flares, which are characteristic of magnetars. They occurred 5 times between May and July of 2005. Each flare lasted less than a second, but released energy equivalent to tens of thousands of suns.
There's been one case of a pulsar which went through several magnetar-like outbursts that require this much stronger magnetic field. and some sort of a restructuring of the magnetic field that suddenly releases a lot more energy than a normal pulsar. So we have at least one case of a link or a missing link between pulsars and magnetars, a pulsar that later showed some magnetar phenomena.
The pulsar-magnetar combo star is fairly young, less than 900 years old. So astronomers think neutron stars may begin their lives as magnetars, then settle down and become pulsars.
It could be that many neutron stars that eventually become normal pulsars actually go through magnetar-like outbursts when they're very young, just a few hundred years old or 1,000 years old. That could be the critical link. We're seeing this one when it's much younger than most pulsars that we see.
Some unusual stars exist in the cosmos.
If something goes up fast enough, it can escape the Earth altogether. Faster still, and it can escape the immense pull of our sun, the force that holds the planets in place. In fact, travel fast enough and you can even escape the pull of the billions of stars that make up our galaxy. The Milky Way. But there is one object out there whose pull is so powerful you can never escape, no matter how fast you go. Not even if you travel at the speed of light. Meet the monster. This is a black hole in action. It is tearing apart a star that has strayed too close. Anything that comes near is destroyed. Our sun is 1 million kilometers across. This is the real heavyweight of the solar system. But if you think our sun is big, think again. There are stars out there that are vast. Their gravity is mind-boggling. But compared to a black hole, even this star is a weakling. A black hole weighs as much as a massive star, but it's crammed into an area smaller than a pea. A black hole is gravity gone mad. Nothing can ever escape. What could create such a monster, something so heavy and yet unimaginably small? With their telescopes was an exploding star. But the explosion was far larger than anyone had ever witnessed before. And in the heart of that cataclysmic explosion, the researchers realized that something astonishing and terrifying had happened. As the massive star died, a monster had been born. What Boyle's team had seen was the death of a star so heavy that when it exploded, its entire mass collapsed inwards instead of blasting outwards into space. This star is absolutely huge. It's 100 times bigger than our sun, thousands of times brighter. But it doesn't just explode. As its surface layers blast outwards, its core is smashed inwards. The center of the star collapses in on itself. Billions upon billions of tons of star stuff crushed smaller and smaller until the whole star is squeezed to a single microscopic point. And from the remains of the dying star, a black hole is born. There is a black hole at the center of our galaxy that is so incredibly powerful it spins whole stars around itself at impossible speeds.
The fact that they're going 1,000 kilometers per second tells us there's 2 million times the mass of the sun of matter there.
This is no ordinary black hole. This black hole is a giant, 2 million times as heavy as our sun. And it's not in some far-flung region of the universe. This black hole is sitting right at the center of our galaxy.